Let's get started with a brief overview of BREEZE MetView. BREEZE MetView is a powerful data analysis tool. Just as BREEZE 3D Analyst analyzes dispersion modeling results in the associated files, MetView allows you to view, analyze, and modify meteorological data. The program has a wide array of raw and model-ready meteorological data formats that it can read from. For example, model-ready meteorological data files such as the ASCII format for ISC ST3 modeling and both the surface.sfc and profile.pfl files from AirMod modeling can be read by MetView. Also included are raw meteorological data formats like CardDeck 144, also known as CD 144, and these represent just a few of the formats that can be analyzed by the MetView product. Once these files are opened, MetView can create custom data roses with accompanying tabular data. The easy-to-use interface makes customizing any display view very simple. Tabular data is also presented, which helps users quickly identify pertinent information from otherwise complicated data formats. Unless you've worked a lot with meteorological data, it's not always obvious what the files contain exactly. MetView helps take away the guesswork involved in meteorological data analysis. As I mentioned earlier, most of you have some experience with BREEZE MetView, which is available from the Tools menu in both BREEZE AirMod and BREEZE AirMet. As you can see from these images below, you can access directly from these other BREEZE programs. Here in the case of BREEZE AirMod, we have the Quick Access Toolbar Project Tools drop-down menu, or you can access those project tools from the Project tab within BREEZE AirMod, and MetView is an option right there. If you go over to BREEZE AirMet, there is a Tools menu which also contains a link to the MetView product. We've decided at this point to make MetView into a product of its own because the new features developed for the program make it so robust that we feel it's the best meteorological data analysis tool available. Regarding the graphical user interface of BREEZE MetView, it consists of a display window featuring 6 unique data functions, as well as a control panel for data selection and modification. The 6 data functions can be divided into 2 groups. We have plotting or graphing on one hand, and then on the other we have tabular analysis. For plotting data, there's the windrows plot, which displays a graphical windrows, the data time plot, which users can create custom time series graphs of meteorological variables, and we also have the brand new data rows plot, where users can see a custom data rows. In conjunction with the plotted data, MetView also has tabular data. The windrows table shows frequency data of the associated windrows plot, while the data table provides an easy-to-read table with headers and statistical data to make your data analysis very simple. Finally, the data rows table, also a new feature, displays frequency data of the created custom data rows. Those of you not familiar with the term data rows, just hold on with me a minute and we'll get to that function in just a bit. Now here, we're going to see an example of plotting in BREEZE MetView. In this case, a windrows plot is shown. On the right side of the screen, you see the display view, which contains the 6 different functions available along the top of the display view as tabs. The display is very large, easy to read, makes your analysis a snap. On the left side of the screen, you see the control panel. Each function within MetView will have a different control panel with unique customization functions. For example, with the windrows plot control panel, you have functions for changing the speed distribution. You can also change the colors of each of the petals that you see, or even modifying the circle grid and how it appears on your screen. There isn't really much of a limit to how you can customize this view. Now in this view, we have an example of tabular data within the program. This image was taken from the data table function and used an AirMod ready surface file or .sfc file. For those of you not familiar with the format, .sfc files are simple text files with columns of data representing meteorological variables. However, even the most experienced AirMod modelers may not know what each column of data represents. Within BREEZE MetView, all of that information is clearly displayed along the top here. No more guessing which column is wind speed and wind direction. You just read it, and you even get to see the units right there and some handy statistical data that follows along. The control panel for this function allows you to select a time period, any customization that you want, and you can toggle columns of data on or off. That's just a small sample of what MetView can do, though. The unique control panels give users free rein over their data analysis. I've broken down the major categories of the control panel functions here. We have the date range, which lets users choose anything they need. You can make a custom range to look at 1 or 2 hours from a file, or there's a long list of pre-programmed ranges already included, such as quarters, seasons, months, etc. There are data functions in the control panel that let users toggle which variables are shown in the tables or which data file they want to view if they have multiple files appended together. The appearance section of each function allows you to change everything from the background color to the font to make each of your images or graphs exactly how you want it to look. Finally, we have the rows appearance functions, which make customizing wind or data rows very easy. You can modify speed distributions, change the number of sectors, redefine parameters of the circle grid, anything you want, it's all there with the click of a mouse. Once you've customized your display view, you can use the Edit menu to export your images or tables for use in another program. The images, such as your plotting and graphing images, can be saved out as raster images like JPEG, bitmap, or GIFs, while tables can be copied and pasted into Excel or saved directly as .xls files. Many new features have been added to MetView to make this the best tool available. First, we have the append function that lets you combine multiple files from the same time period for easy comparison. Another new feature is the data rows and associated data rows table. For those of you not familiar with wind or data rows, think of it like a compass rose with a little extra data added to it. Using this feature, you can create custom plots of various meteorological parameters or pollution data against wind direction. Finally, we have the file archiving system similar to other BREEZE products and now added to MetView. This system will save all appended files as a single zipped file, so all of your data remains in one single package rather than scattered around on your local computer or your network. Now let's look at the append function first. The only limitation to this function is that every appended file must cover the same time period as the original file that it is added to. The files do not have to be the same format, only the same time period. One important application is that you can append non-meteorological data, such as pollution data from a database, to a meteorological data set. Appending is also useful for side-by-side comparisons of meteorological files in the associated plot or table views in MetView. In the image you see here, we have a time series plot of wind speed from 2 different meteorological files. Now say I had performed a modeling analysis with these 2 files and I got drastically different results between the 2 over the course of these 3 days, February 12th, 13th, and 14th of this given year. I noticed that one file, the one represented with this black line, has a significant number of calm hours as compared to the dataset represented by the green line. So now I have one possible explanation for the differences in concentrations. The black line file has more calms and thus fewer hours from which it actually calculated the concentrations from. Another new feature available in BREEZE MetView is the new data rows. While wind roses only provide the frequency relationship between wind speed and wind direction, data roses are much more versatile because they allow users to review any meteorological variable within the data file against wind direction. In this example, I've plotted surface roughness in my data rows. And some of you might be thinking, why would you want to plot surface roughness against wind direction? Well, I'll give you an example here. This is useful because if I had not processed this data myself, I might not know what surface characteristics were given to AirMet to generate this AirMod surface or .sfc file. By reviewing the data in the data rows, I can assume that the region from this west-northwest wind direction and spanning all the way down to my south-southwest wind direction, they have very low surface roughness and likely have a significant water feature located on this side of the meteorological station. So if I'm trying to choose a .sfc file that might be appropriate for my modeling domain, and I look at this, see a big water body to the west, whereas my facility might not have any water anywhere near, I can probably assume that I need to keep looking for the most representative meteorological file. But the features of the data rows are not limited to just what's available within your Met file. I've got these two new features. They're great by themselves, but when I combine them, I can take my analysis a step further. Imagine you have pollution data from an ambient monitor, such as that which comes from the US EPA AIRS database. The pollutant data that comes from this database can be modified and appended to a meteorological data file within BREEZE MetView. Then, once I've appended the data, I look at my data rows plot view. Suddenly my data rows has become a true pollution rows. This modified pollutant data from the AIRS database is available for purchase from the data processing group at BREEZE software as well. So now let's look at this example of my pollution rows. In this case, I took my AirMod Ready surface data file and I appended some ozone data to it. You can see here, I've got the same old display as before as my data rows plot view. And then my data now has some extra variables. It's not just the 2004.sfc file. I now have ozone from one monitor and ozone from a second monitor. In this case, I chose the 9010 monitor to look at my ozone data from. So how would you use a pollution rows? Well, first, let's make up a fictional facility. Here we see on the map the imaginary facility of Site A. We've given it a very generic name. This site is located to the west of an ambient air monitor, which is centered on the location here that has been plotted in Google Earth. So maybe Site A was recently accused of emitting too much NOx, and this led to very large spikes in ozone concentrations at this monitor. Well, by using my pollution rows created in BREEZE MetView and then overlaid at the site of the monitor in Google Earth, I can use this image to show that the vast majority of ozone measured at this monitor comes from down here in the southeastern quadrant, and even a little bit up here from the north and northeastern quadrants. So the wind rarely blows to the monitor from my facility's western location. In the end, this simple data analysis and graphical overlay can quickly prove that Site A is certainly not the culprit of high ozone concentrations at this monitor. And in the end, this could save thousands of dollars in emission inventories, dispersion modeling, possible permitting, etc. So you can see this pollution rows really can be a great tool to have. Finally, we have our last new function, the file archive system. As in many of our current BREEZE products, we have added the zipped project archiving to MetView. The MetView zip file with a .mvz extension allows users to save all the files from an analysis into a single archive. In the previous pollution rows example, the archive would contain both the meteorological data file as well as the pollutant data from both monitors. This system gives the benefit of packaging multiple files into one, thus making file organization much more simple.